Okay, let's get started. So I hope all you guys know that on Wednesday, just before midnight, please don't hand it in at 11:59, but at least a little bit before that. Your first assignment is due on Wednesday. You hand it in on my courses. The submission instructions are in the PDF for the assignment. Put it into a folder called Assignment 1 and then compress it. You can do that easily, like right-clicking on the folder, compress it, turn it into a zip file. We don't want anything other than a zip file. There should only be .java files and .txt files in there. Don't give me any class files because they're useless to us. And hand that in. If you need help on the assignment, I'm happy to help you. I have office hours today and Wednesday at 1:30 to 3. There's the discussion forum. There's lots of questions on the discussion forum. It's great. Most of the common questions about the assignment have already been answered on there. So check it out or post your own questions. And the TAs are available to help you. So make sure that you complete the first assignment. It's the best way to learn the material for sure. Okay. I showed you guys coding bat last time. Another great way to learn the material. I'll probably go through this exercise has team today. Go there, try it out. It's example methods for you to write, and then when you hit go, it will test whether your method works or not. It's a great way of learning the material as well. Okay, so what am I going to talk about today? I'm going to just briefly review if structures that I talked about last time. I'm going to go over a few common if statement errors that come up all the time. We're going to get through ands, ors, and nots. I'll talk about Boolean resolving of equations. And if we have time, I'm going to get to casting and conversions, because you'll need that for the second assignment, which should be out soon. Okay. So last time I talked about if structures, and I'll have an example on the next slide. Where in an if structure, the first test must be an if. You must have an if first. You can have as many else ifs as you want, including 0. And then you can, or you don't have to, have an else at the end. And then what is Java going to do? Java is going to test each case from the top to the bottom. And when a condition is true, that block will be executed. And then after a block executes, Java skips down past all the other cases to the end of the if structure. And then if there's an else block, that will execute when no other block is executed. So that's a lot of words. Let's see this in action. I showed you guys a mini calculator last time where we could do something like run calc 1 plus 2, and that should print out 3, because that's very exciting. Have something like this, calc example. The first 3 lines take the 3 input arguments, and they convert it. So for example, I'm taking the first argument and I'm doing integer.parseInt. That will try to turn that string into an integer. Here it's taking the second input argument and putting it into the string operator. Here it's taking the third input argument and parsing it again as an integer. So now we have our 2 ints and our operator. We set up our double result is equal to 0, and then we start doing our testing. So here's our if structure. We have an if, an else if, and then an else. The first test to see is whether that operator equals the plus sign. So here we're doing a string comparison. We're checking whether a string is equal to a string. You have to use dot equals. It doesn't work if you use the double equal sign. And if that equals, then our result is equal to a plus b. If this test doesn't pass, then it checks to see the next one. If our operator is equal to the star sign, then the result is equal to a times b. I suggest to you that if you want to practice this, you put in as many other operators as you want, like divide or mod or subtract. And then we have this else condition here. The else will execute if none of the other conditions do. So this will say there's an error. This operator, it doesn't know what it is. And then finally, we print out the result. So that's an example of an if structure. Any questions about that? Yep.
Why do you print the result equal to 0 before the if statement?
You have to give it a default value because in the else here, it's not giving it a value. And whenever you print out, whenever you do a calculation, every variable has to have a value. It has to be initialized. If you don't give it a default value, then if this else condition executed, it wouldn't have a value. Does that make sense? Okay. So I also showed you guys the absolute value method. Also lots of fun. So it takes a number that can be negative or positive, and it will return the positive version of that number. So if you have 4, it returns 4. If you have negative 9, it returns 9. If you have negative 57, it returns 57. It just gives you the positive version of the number. So you can do something like, if the number is negative, multiply it by minus 1 to get rid of the negative sign, and then return the number. So I showed you guys many different versions of this. Here is ABS, the absolute value method. If x is less than 0, please ignore the semicolon. That shouldn't be there. If x is less than 0, then we do x is equal to x times negative 1, and then we return x. Here's another version, absolute value 2. If x is less than 0, we return x times negative 1 right away. Otherwise, we return x. So it's another equivalent version. We're just returning as soon as possible. And then I showed you guys this third version where we do, if x is less than 0, we return x times negative 1. And then we don't have an else case here. We just have return x. And we don't need the else here because the last instruction is only executed if this block wasn't executed. So if x is less than 0, then x times negative 1 will be returned. Otherwise, we're just going to return x. So here are 3 different versions of the absolute value method. They all work the same. It's important to understand how all 3 versions work, because you'll see many times methods that are written in different ways. It's very hard for me to show you exactly how to write methods because everybody is going to write them a different way. So it's important to understand all. It's important that when you see a method, when you see code, you understand what it does. There's some pattern recognition in programming, but it's really about understanding what each instruction does so you can figure out what that code means. That's a hard thing about programming. Okay. Any questions about the absolute value methods? Okay, let's talk about if statement errors. A few common questions I get. So what's wrong with this if block? If I have something like this, I already said to you, it's that darn semicolon, which I accidentally left in my slides. And why is this a problem? Because if you have a semicolon at the end of an if condition, then what's inside the if block will always execute. The compiler will not tell you about this problem, and I don't know why it does. It should tell you about it because it's such a common thing. Don't have a semicolon at the end of an if block, or at the end of an if condition, sorry. And the reason is because the if statement starts a block of code, we don't end a semicolon. This is a test. It will execute code, so we don't want to have a semicolon there. And to put it another way, either we add braces after a line of code or a semicolon, never both. So here, this is an if block, so we have braces. So if we have braces, we don't want to add a semicolon. So methods have braces, so we don't add a semicolon. Does that make sense? Very common mistake. I see it all the time. I have done this to myself. I think once I spent like an hour or something super embarrassing. And it's because I put a semicolon in there, and then the code inside was always running, and it was something super simple like this, and I was like, if x is less than 0, like I can't get that test wrong, kind of thing. Screwed me up. It's very easy to do. So if you're having a problem, check for the semicolon. Okay, questions about that? Okay. Trying to save you guys hours of time. And I think it was at like 2 or 3 in the morning. It was brutal. Okay. So what's wrong with this code? Another very common error. So going back to the discount example, public static double get discount int age. If your age is greater than 65, double discount is equal to 10. Else if age is greater than 55, double discount is equal to 5. And then we're returning discount. You may think that it works, but the compiler is going to tell you that it can't find the symbol, it can't find the variable discount. Can anyone take a guess why it can't find the discount variable? Yep.
Because there's no possibility for what discount is if it's under 55 and 65?
Not quite. Anybody else? Yep.
Because he didn't initialize it?
Initialize it. That's more on the right track. So why does it say the variable cannot be found? This actually goes back to scope, where in scope I was talking about if you declare a variable in one method, it can't be accessed in another method. So actually, it's a little bit more nuanced than that. What we say is that variables only exist in the block within the braces where it was declared or created. So I'm going to show you. I'm going to tell you what that means. After I show you the fixed version of get discount, more of a standard form. So if you're doing something like get discount, you usually do something like double discount is equal to 0, give it a default value. If your age is greater than 65, discount is 10. If your age is over 55, your discount is 5, and then you return the discount. That's usually the standard way you do things. Or another way of doing this, if your age is greater than 65, you return 10 right away. Else if your age is over 55, you return 5 right away, and then else return 0. That's another way of doing that method. So another version where each path returns a value. So let's talk about scope a little bit more. So I said that variables exist after they're declared. If variables continue to exist if new blocks are opened. So what does that mean? Here I have int x is equal to 0. I'm declaring and initializing it. Here I have an if block. If x is greater than or equal to 0, x will continue to exist within that if block. Here I'm declaring and initializing y. Int y is equal to x plus 1. But here it's the end of the if block. So at the end of the if block, any variables that were only created within here, they stop existing. So I can't access y outside of the if block because y was declared within the if block. And then if we have double z is equal to 0, double z, that variable only exists after it has been declared. So variables stop existing after the block they were created and is closed. For example, y stops existing when the if block is finished. So let me show that to you with some colors, because colors make us happy. And you can see how I can't draw straight lines at all. Well, this one's pretty good, but that one's terrible. So here it's showing you the scope of a variable. So here I'm declaring int x. I'm declaring it at the top of the main method, which means it exists until the main method stops. Here I'm declaring z at the bottom of the main method. Z only exists until the main method finishes, because this is the block. You can see here's the start of the main method, here's the end of the main method. So when the method finishes, when the block finishes, the variable disappears. So x will also exist within here. But if we look at y, int y is equal to x plus 1. We're declaring it within this if block. And you can see the scope. The scope ends when the if block stops. When the block stops, all variables that were created or declared within that block, they cease to exist. And so they can't be used anymore. If I try to access it out here, the compiler would say, I don't know the symbol y. So you have to worry about the scope of your variables, especially when you start using ifs and elses. This variable only exists within this block right here. Questions about that? Okay, so if there are no questions on scope, I'm going to go on to ands. And we use ands when we want to make more complicated decisions, when we want to have more complicated Boolean expressions, and then I can write even more interesting programs. So we could write a program to decide whether to run outside. So say this program takes temperature and it takes is raining. So we won't run if it's raining because they don't want to get wet. If it's too cold, say minus 20, or when it's snowing outside because I don't like snow. So we could write something like public static boolean should run, takes the temperature and takes is raining. We assume we can run. Boolean run is equal to true. And then if it's too cold, if the temperature is less than minus 20, we set run to be false. If it's raining, we set run to be false because we're sweet and we're made of sugar and we'll melt. And then we return the run variable. We'll return true or false, whether we should run or not. So we set it. We assume that we can run. If this test passes, we will not run. If this passes, then we won't run, and then we'll return whether we should run or not. So assume we can run. If we have bad conditions, then we can't run. So let's figure out a way to make an expression to tell if it's snowing. So that's below 0 and is raining. Sorry for the typo. That's the last one I'm going to make this month. So we said that it's below 0 and it's raining. So we're using the word and here. So we're going to connect Boolean expressions together with the AND operator. So let's see a messy way, a confusing way of connecting these Boolean expressions together. We could say that it's not snowing, and then have one test to see if it's raining. So it will test to see if it's raining. If it's raining, then Java will execute what's within that first if block. Here's another test. So if the temperature is less than 0, then it's snowing. So in order for this instruction to execute, it has to be raining and snowing. And I haven't really showed you guys nesting ifs before. You can do it, but it can become very complicated to figure out the conditions for when stuff happens. So usually we don't nest too many things together. But I'll show you examples of nesting later on when you need it. So this works, but it's a little bit more confusing than it needs to be. So let's see a better way. I think that this is pretty clear. It's Boolean is snowing. That is the result of testing whether it's raining and the temperature is less than 0. So is snowing is true if and only if the Boolean values on either side are true. So this variable is only true if this is true and this is true. If it's not raining or if the temperature is above 0, then it's not snowing. So is raining must be true and temperature must be below 0. Any questions so far? Okay. So we can have two different ways of writing it. They're the same. Boolean is snowing is equal to is raining and the temperature is less than 0. Or you could say it's snowing if the temperature is less than 0 and it's raining. So you can put them in either order, doesn't matter. So we can reverse them if we want. So let's talk about the ampersand. The ampersand is that weird little symbol that when you guys write it on the midterm and the final, I have to decipher. Because some people just write, it's like they write like weird G's and then I have to figure out what that is. So spend some time practicing it. So it's called the ampersand, and the result is true only if both of the Boolean expressions on the sides are true. So what does that mean? If you have something like true and false, it's false. And I'll have an example later of going through showing you examples of true and false and resolving the Booleans. It's a later section. But we said that something is true only if both sides are true. So true and false, one of the sides is false, so our result is false. In computer science, we like to put things in tables. So here's a table. You don't need to memorize it and be able to write it out like this. Just think about it. Something is only true. The result is true only if both sides are true. Otherwise, it's false. So to put that as another example, I can see the stars only when it's night and it's a clear sky. If either one of those is false, then I can't see the stars. Does that make sense? Okay. I had in my last lecture, I had the moon there because I totally forgot that you can see the moon during the day. So I'm not in astronomy. It's different. It's a different field. And what I covered by saying that the moon in the day, that's a fake moon created by the CIA. So, which is a pretty good cover. Question? Nope. Okay. Anyways, so let's try another example with and. A creative method is in middle, because I know you guys love methods. So this is a method that takes three doubles, left, num, and right. And it's going to return true if the num is between left and right, and it's going to return false otherwise. So I'm going to write this code. It's pretty small. Okay. Public class in middle. Public static void main. Public static returns a Boolean, is in middle, and it will take the number. It will take the number on the left, and it will take the number on the right. And we just move that down. Okay. Okay. So what we're going to do when we're calling this, we're going to say Boolean result is equal to is in middle. So let's test to see if 5 is in the middle of 3 and 7. So it returns true if 5 is in the middle of 3 and 7. So what we could do is we could do something like Boolean check left. See if the left number is less than or equal to the number, and print that out. check left. I'm going to copy and paste that, and hopefully not to make too many errors. Check the right. On the right, we're going to see if the number is less than or equal to the right. And then we will return whether our check on the left passed, that's true, and our check on the right passed. Let's compile. How many errors? None. I meant to print this out. Result. Okay. So if I run this, if I run it with is 5 in the middle of 3 and 7, my result is true. Why is that? I check my left versus my num. My num is 5, my left is 3, so my check on the left passes. I check it on the right. Is 5 less than or equal to 7? It is, so this is true. And then I'm checking to see if both tests are true. If I do something like is 1 in the middle of 3 and 7, this should fail. So here we can see that the check on the left failed because 3 is not less than or equal to 1. So my check on the left failed. So when I do my check left and my check right, one of those is false, so it returns false. So any questions about that? Okay. So I did all these prints. You really don't need to have 5 different lines to do this computation. You can shorten it down to 1, but I want to show you all these different pieces so that you understand what's going on. Let me show you another example on the slides. Oh yeah, I did want to say about this. Here I just have my simple is in middle. So it checks to see if the numbers is between the left and the right. And I'm just putting it all into one expression. Boolean in middle, it's set to be whether the left is less than or equal to the num and the num is less than or equal to the right. So it's the same thing that I had before. I'm just taking those 2 checks. Instead of having those 2 checks in 2 different Boolean variables, I'm putting it into one big expression, and then I'm returning it. And I want to show you this because often when you're doing something like this, we're doing left less than and equal to num, and the number is less than or equal to right. What people want to type is something like left is less than or equal to num, is less than or equal to right. This works in some programming languages, but this will not work in Java. It doesn't work. You have to have the and in between here. So don't write this code down here. It's very tempting, but don't do it. It's wrong. Okay. I want to show you an alternative implementation of this method. And it's to show you that most of the time you don't need to have ands. You can get away without them. For instance, you could write your code like this, and to say that if your number is less than the left, you return false. If your number is greater than the right, you return false. And then otherwise, you return true. So it's another way of expressing it. It's the same. It will give you the same results. And that's the tricky thing about this logic stuff, is that you have to think through the different cases. And are the cases for this method, is that the same as for the other implementation that I showed you before? Are they equivalent? You have to go through the cases and maybe even write it down in which cases they work and which they don't work. Can be hard to think about. So here there are multiple points where we return from the method. And to avoid errors, all your cases have to be covered by a return, because you've said here that you're returning a Boolean, so you have to return either false or true in every case. It doesn't work otherwise. Okay, any questions so far? Yep.
Can you use the and sign multiple times?
Yeah, you can have as many ands as you want, but if you have more than maybe 2 or 3, you're probably doing something confusing. It's nice to break it up, to only have short little blocks. And not have, if you have 10 ands in a row, you're doing something wrong, for sure. Okay. So there must be a return statement on every path through the method. Okay. So let's talk about ORs a little bit. So ORs are just like ANDs, so this will go a little bit faster. So we could say that a grade is invalid if the grade is under 0 or above 100. We want to say that grade is invalid to the user. So we could have code like this, where we take the code as an input argument and say you entered grade. And then we have a Boolean that stores whether or not that grade is invalid. So we'll say that it's not invalid if our grade is less than 0, is invalid is equal to true. If our grade is over 100, is invalid is equal to true. And then if the grade is invalid, we'll print out that grade is invalid. So here we're doing a test to see if it's less than 0. Here we're doing a test to see if it's greater than 100, and we're doing the same thing in both. So I say to you that you shouldn't repeat code like this, because if you're repeating code, you're probably doing something wrong. So we can simplify this using the OR operator. So it's the same thing as before, but this time I shorten it down, and then I'm storing in is invalid. I'm storing the result of testing, is your grade less than 0, or is the grade greater than 100? So if the grade is less than 0, or the grade is greater than 100, then we'll do that instruction. So to talk about OR, it's called vertical bars. You have to have 2 of them. For me, it's above my enter key. So for the ORs, the result is true if either one of the Boolean expressions on the sides are true. So for example, if you have true or false, that is true. So in a truth table, if there's a true on either side, then the result is true. That's the best way to put it. So as an example, we could say that it's dark if it's night or the lights are out. So is dark is only true, is dark is true if it's night or is lights are out. So just to show you a Coding Bat question that talks about these, they love ands and ors on Coding Bat. So I just want to show you a quick little method and show you my solution and their solution, just to get you used to ands and ors, because we're going to use them all the time. So in this method, we say that a number is teen if it's in the range of 13 to 19. So given 3 int values, return true if one or more of them are teen. So is one of the numbers between 13 and 19. So here, 13, 20, 10. 13 is between 13 and 19. 20, 19, 10. One of them is between 13 and 19. So you guys couldn't do this before because you definitely need, do you need ands and ors? You probably don't need them, but it would be really complicated otherwise. So it becomes pretty simple. Let me show you my solution. So my solution, I've created actually 2 methods here because I love methods. I'm saying that one of these is a teen if the first one is a teen, or the second one is a teen, or the third one is a teen. And then it calls the isTeen method. So this returns true if x is greater than or equal to 13 and x is less than or equal to 19. So this method, very simple, returns a Boolean whether that variable is within 13 to 19. And then this one just calls that method 3 times. Is the first one a teen, or is the second one a teen, or is the third one a teen? Any questions about that? I'm calling the isTeen method 3 times, and I'm returning true if one of them is a teen using OR. And then down here, I'm using AND to make sure it's between 13 and 19. Okay. Let me show you their solution, which is ugly. So it does the same thing. They're doing is A greater than or equal to 13 and A is less than or equal to 19, or B is greater than or equal to 13 and B is less than or equal to 19, and same for C. So this works. I would say that this is more confusing. If you want to change what your test is here, you have to change it in 3 spots. So you're way more likely to make a typo. For me, my rule is that if I'm writing something more than 2 times, you should just make it a method or something, because typos are really hard bugs. If you make a typo, sometimes it can take like 20 minutes to find it. So it's much better to put things into methods like this, and then you can think about this method and test it, and then you can just use it 3 times, rather than in their solution, you're just copying and pasting, which is ugly. And I also want to show you with this one, you can see that you can have lots of ands in an expression. You can use ands and ors together. But when you use ands and ors together, you have to put brackets around it for the precedence. But I would suggest to you, don't do this. This is more complicated. It's harder to think about and figure out. Divide it up into multiple pieces. Any questions about this? Yep.
About proper code writing and stuff, indentation, and all that kind of. In this case, like we're writing A greater than or equal to 13, and it's all sort of stuck together. Is that how we write them all the time for that expression, or have we been putting spaces?
I like to put spaces.
Does it matter? It
doesn't matter, but I'm always correct, so. Should do it my way. No, but I mean, I like to space it out because for me it's easier to read. And like I've said, the most important thing is that your code should be easy to read, because that's how I know it's obviously correct. But good question. Okay. So let's just to finish off, let's talk about nots. So if we want to test the opposite of something, how can we do that? So for example, you could have something like, is it snowing? It's snowing if it's raining and the temperature is less than 0. And here I want to print something only if it's not snowing. So I could do something like this and use an if and else. So if it's snowing, I'm doing nothing. Else, I'm going to print out, yay, no snow today. But I'm saying that this is useless code. I'm not putting anything in here. Like half of this structure right here is useless. That's bad practice. That's you're going to get errors that way. So how can we make this simpler? How can we easily check to see if it's not snowing? So we'll use the not operator. So the not operator is with the exclamation mark. So I put it here in front of the variable I want to check. You put it in front of the expression you want to negate. That's what you call it. So you would say this as if not is snowing. So if not is snowing, then we print this out. So this will only execute if this variable is false. Let me say that again. This block will only execute if is snowing is false, because it will take the false and it will flip it to true. Let me talk about that. So we have the exclamation mark. It gives the opposite Boolean value. So if we have not true, that's false because of how logic works. So if you have not false, that's true. If you have not true, that's false. It just flips it. So as an example, you could say that something is a cat if it's fuzzy and it's not a dog. That's probably not the definition of a cat. That also covers many other things, but just as an example, that's how to use it in a test, and that's how to read it. Something is a cat if it's fuzzy and it's not a dog. My advice is that in life, keep it positive. So when you're naming something, like when you're naming a variable, use something like is valid. Keep it positive, because it's easy to reason about not is valid. So not is valid, that means that the if block executes when something is not valid. Because I see people, and sometimes they have code like if not is not valid, and then I'm like double negative, okay, let me flip that round, okay, that executes only when something is valid. Like that takes me time to think about. Things shouldn't take time to think about. So don't have negations in your variable names, because it's way harder to think about. Okay. And I just want to show you an example, something that might come up, might not come up, because you guys will try to keep your expressions simple. But I just want to show you, like I'm going to have something, Boolean is snowing. We saw it's raining and the temperature is less than 0. That's pretty simple to think about. You can use something called De Morgan's laws and flip around that statement. So is raining and the temperature is less than 0. That's logically equivalent to not is raining or temperature is greater than 0. They mean the same thing, but one way is way harder to think about. So as you gain experience with logic and using ands and ors and nots, you'll learn how to write your tests and your expressions so that they're very simple. Okay. Any questions about that? Okay. So I might only go through one of these. Just to give you examples of thinking about ands and ors in practice, there's an example on the assignment warm-up. So it's stuff like this, trying to figure out trues and falses, figuring out what that evaluates to. So if I have this whole expression, is that true or false? It's going to say it's true, and I'm not expecting you to get that in 1 second. You go through it one step at a time and you simplify. So ampersand is and, the vertical bars are or, and the exclamation mark is not. So I'd write this as true and false, or not true or true, or not false and false or true. And you just need to work through it one step at a time. So true and false, that becomes false, because one of them is false. True or true is true. I'm keeping the false here. False or true is true. We'll simplify again. False is false. Not true is false. False and true is false. False, false. Not false is true. False, false, or true is true. So it's a little bit tedious. It's really hard to say. But it gives you practice with ands and ors and nots, and I'm going to suggest that this will definitely be a test question, because you need to understand the logic, because this is how you code. This is how you you make decisions in your code. Okay. I don't feel like talking about true and false, so we won't go through this one. But I want to say, if you have variables like a is equal to true and b is equal to false, and I give you something complicated like this, it's the same thing as before. You just need to substitute in a and b. So now you have this, and now you know how to work through it. I'm just going to skip it. But you just simplify down, and then you get false. Okay. Does So any questions on ands, ors, or nots before we move on to casting? Yeah.
So in this part there, you had false or true. And so like in what order did you execute that? Because like if you were to go false or false, that's true. Or that's false.
Yeah.
And then it's like false or true, and then you get true. But if you were to go the other way and go false or true,
Is true.
it's true.
And then true or false is true.
Okay, so it works either direction.
It works either direction. Yeah. But if you start mixing ands and ors, that's where it gets complicated. That's where you need brackets. Okay. Okay. Anybody else? All right. So we're going to get into casting, which is turning metal into different shapes in other fields, not here. Casting is when we're changing the type of a variable. So in Java, you've already had 10,000 errors where you have the wrong type. It's part of warning programming. Sometimes we have a value in one variable that we want to convert to another type. So for example, we saw how to get a random number from 0 to 1, or just very close to 1. And we saw how to scale that number up. So now we know how to get, say, a number between 0 and 99.99999 repeating. But the problem is, I showed you how to do that and get a double value. So what if we want a random integer value? So I showed you this. Double rand, math out random, gives you something between 0 and 1. And then we scale that up by doing times 20. And now we have something, what's stored in rand 20 will be between 0 and 19.999, and so on. So the number we're getting at the end here is a double, and we want to put it in an integer. If you just put it in an integer value, it gives us an error because we saw that integers store less data, they don't store the decimal point. So here's the same code. Double rand 20 is random times 20, so that's a double. If I take this double and I try to store it in an integer, Java will complain and will say you can't store a double in an int. You're losing data in your conversion. So what we want to say to Java is that sometimes we want to say, don't worry about the decimal point. I want you to throw it away, and I just want you to put the result in an integer. So what we do is that we put int, and then we put brackets in front of the value we want to cast. So that's what casting is. You put an int with the brackets in front of it, and that says to Java, I want you to take that value, and I want you to force it to be an integer. So what we say is that this is a double value. We're casting that double value to the integer type. So if you have something like this, double x is 20.456. We print it out, 20.456. That's fine. Here we're taking that x value and we're casting it to an integer. And placing it into int y. When we print out y, we're going to have only 20. So when we're casting to an int, we're throwing away the decimal. Java forces you, if Java is trying to protect you, it says if you want to throw away the decimal, you have to explicitly say, I want you to force this to be an int. Does that make sense? Any questions about that? We're casting, and when you're casting, you're saying to Java, I demand this be an int. So you have to write it in the brackets before the value you want to cast. So casting is a little bit tricky. If I do int num is equal to, and then I'm casting math.random. Can anyone predict what's going to happen here? What does math.random give me? 0 to just less than 1. So if I cast it to an integer and I throw away the decimal, what do I get? 0. Good, good, good. Because it's always 0.0 to 0.9999. So if you cast it, throw away the decimal, you always get 0. This one screws me up all the time because I forget about it. So if you're casting, and just as a little motivation for why I'm talking about this now, there's a possibility that on your second assignment there may be something where you have to get a random number from 1 to 6 as an integer. So this is why I'm showing it to you now. If you write something like this, if you're trying to get a random number from 0 to 20 as an integer, it's very tempting to write something like this. Math.random times 20, and then you put the cast in front, and you think that the cast happens last. But instead, the cast to an int is very sticky, for lack of a better word, and it happens before other operators. The cast happens before the multiplication. So it applies to the math.random before the multiplication, so you get 0. So we're always multiplying by 0, and then you're always going to get 0 in your number, and then you're going to wonder why your program never gives you anything different. It's very, very annoying, very common bug, happens all the time. And that happens because the cast applies to the value it's in front of before anything else. So if you want to avoid that, you put it in brackets. Very simple. You do math.random, you scale it up to between 0 and 19.999 whatever, and then you do the casting. So what values is this? This will give you 0 to 19 as an integer. Any questions about that? Okay. I showed you this last time. What if we don't want our value to start at 0? If you want to generate a number from 5 to 20, think about adding 0 to 15, adding that onto a 5. So you might have something like this. So you start with your 5, and then you add on your math.random times your 16. So how do you figure out what this gives you? Your math.random gives you from 0 to 0.9999 whatever. So when you times it by 15, it'll give you from 0 to 15.999 whatever. You cast it to an int, so that will give you from 0 to 15 as an int, plus 5 gives you 5 to 20. So lots of different things happening in here, especially with the cast. Make sure you go through it and you know what the different parts of that calculation mean, because you're going to need this for your second assignment. Okay. So it's 5 plus 0 to 15. Questions about this so far? Okay. Yep.
Why are you multiplying by 16?
You're doing times 16 because math.random will never give you 1. So when you do 0 to 99999 times 16, you're only going to get from 0 to 15.99999.
And then casting the input could lead to 0.99. Giving you the 16 you want.
Yes, when you cast it, then you get 0 to 15 as an integer. So yeah, you're going to take this form, and then on the second assignment, you're going to change it because you're not going to go up to 16. You're going to go up to another number. And I showed you this before. It's a great practice question, and it's a warm-up question, I think, on the second assignment. Creating a method with 2 parameters, a minimum value and a maximum value, and then playing around with this. Can you get a random integer between those 2 numbers? It's a warm-up question on the next assignment. So let's talk about conversions a little bit more. And I'm going to show you some conversion examples. Talked about casting. I'm going to show you more examples of casting. And I'm going to show you conversions between integers, doubles, strings, and booleans. It's going to look like a lot of tables and things to memorize. It's not. It's very consistent. There's actually not too much to memorize. So it sounds way more complicated than it is. And I also haven't mentioned characters that much. That's because we're going to see characters maybe next time, maybe next week. So also worry about characters in this class, but you won't convert between integers and doubles and characters. Okay. So if you want to convert an integer to another type, if you want to convert an int to a double, you just assign it, and Java actually does the conversion automatically. If you want to convert an integer and turn that into a string, you use concatenation, and you use this little trick where you just have the two apostrophes right next to each other, and this uses concatenation, and it will make this like a 1 and a 5 as a string, and then you can't turn an integer into a Boolean. If you want to convert a double, we saw to cast, you would take something like 6.6, you cast it using the int. So int x would only have 6, so you're losing information there. If you want to turn a double into a string, you just use the same trick, and you do plus and then empty apostrophe signs. And then you can't turn a double into a Boolean. That doesn't make sense. Okay? If you want to convert a string into another type, this is the stuff I showed you before, where integer.parse int, and then you give it some digits, and it'll turn it into an integer. Same thing for double, it's double.parse double, and then if you want to parse a Boolean, you give it a string here, and it will try to turn it into a Boolean or not. And then to convert Booleans to another type, the only thing you can do is you can use the concatenation string to turn a Boolean into a string. So 4 very small little tables. Okay. Any questions about the conversions? Those are the conversions you're going to see in the class. Okay. And I think, okay. No, I'll go through after, but I just want to show you these slides just for information, just because I get a lot of questions on them, and it's about the different variable types in Java. Because it's not just int, double, string, Boolean characters. There are many others. We're not going to talk about them except for these next slides. So we're not going to test you on these following slides because it's too much information to care about, but I want you to get a sense of the different variable types. So there are types that hold numbers without a decimal. We have our friend int here. It's 32 bits. And the range that it holds is around negative 2.1 billion to positive 2.1 billion. There are also longs, which are twice as long. They have a much larger range. And then there's also short and byte, which hold smaller ranges. So if we really cared about this, we would choose an appropriate range for the stuff we cared about. In this course, we're not going to worry about that. I just want to show you that they exist. There are also Booleans and characters. So Boolean holds true or false, and a character stores one symbol, one character. I was looking, and apparently it's totally broken. It doesn't handle emojis very well, because emojis are pretty new. Back in my day, we only had the colon and then a bracket to make a smiley face. None of this fancy stuff. So there's a link there just for interest. You get lots of questions about floats and doubles because many other times people use floats. As you can see, floats are half the size of a double, and they can hold different ranges. And it's called closest to zero val and farthest from zero val because floats and doubles they only have a precision how close to 0 they can get, like 4.9 times 10 to the negative 324 is very close to 0, but there's things in between that value and 0, and there's a maximum range as well. So they have like a minimum and maximum range, and then there's 0 in the middle. And then actually, if you look at floats and doubles, their precision actually matters, how far from 0 you'll get. So it's very complicated. So we're not going to talk about that, but if you're interested, there's a link. These numbers have special values. They have 0, positive infinity, negative infinity, and then we already saw in this class not a number, which we won't really talk about again. Okay. So we're not going to worry about the details, especially for converting between floats and doubles. But if you're programming for real, you want to pick an appropriate variable type. You saw that some variable types are twice as large as others, which doesn't matter when you have, say, 5 variables. But if you had 1 billion variables, which isn't impossible, you'd be using twice the size that you need to. And in a real program, you really need to worry about losing information with casts. Because I have an example here. Here, I'm storing 4 billion as a double. Even though it's a 0.0, if I try to cast that down to an integer, so I'm just going to cast that really big number, and then I'm going to print it out. And my result that prints out is 2.1 billion. So now it's thrown away 2 billion or something. Why is this 2 billion? It's because if you print out the maximum value that an integer can hold, it can only hold 2.1 billion. So here, even though even though I have a number that doesn't have a decimal part to it, when I cast it, it's throwing away part of it. I've gone down from 4 billion to 2.1 billion. If this was your bank account, you would really care about that. And why is that? Because an integer can only hold up to 2.1 billion. So you have to care about these types if you're doing a real program. Okay, and I showed you this before. Don't use floats or doubles for currency because there's issues with binary representation. If you're doing something like +1 plus +1 plus +1, that's not quite equal to +3 and to 0.3, sorry. And that's just the representation, how they're stored. Okay, before you go, we got enough time. What I want to show you is I want to show you another example. I want to show you a login program with ands and ors. Before that, any questions on this? Any questions about different variable types? Okay, I want to show you some ands and ors, just to give you a little more practice on that, because it's an interesting example. It's more of a real world example, something you might actually write. So I want to show you a login program so that you can protect your bank account with 4 billion in it that you get after writing all these apps in Java. Okay. Yeah, let's do it this way. Public static boolean can log in. So we're going to create a method that takes someone's name and takes someone's password. Let's go over. Okay. So take someone's name, take someone's password. And then we're going to do boolean, it's me, if the name is equal to my name. So I need to use dot equals and spell my name right. So it's my name and the password dot equals. You have to use dot equals when you're comparing strings. And the password equals my secret password that I use for everyone. Everything. Please don't tell anyone. So Boolean is Bentley. and then we're going to return if that's true or not. Save that. Okay. We'll just call that, store that in a method, and I'm going to pass my name to that method, and I'm going to pass my secret password. Then we'll just have a printout method. I logged in. Then just print that out. Okay. Accept the formatting. Go clean. Okay. Compile. No errors. Run. Logged in. True. Very simple. What I want to do is I want to make this a little bit more complicated. So now, if I'm passing Bentley and Kitties, I'm comparing Bentley and Kitties to what's stored in this method. So it's testing to see if my name is equal to Bentley and my password is Kitties. That gets stored as a true or false, and I'm returning that, and then I'm printing it out. So very simple. Now you can only log in as me. What I want to do is I want to have another one. So Julia is the other instructor. We'll test to see if it's her name. And I'm going to guess what her secret password is. She's from Italy. I'll assume her password is Italy. It's called social engineering. It's how to hack into things. And that's a Boolean. It stores if the name is equal to Julia and if the password is equal to Italy. So it gives you a true or false. And now, we want to return whether your details are the same as mine or if your details are the same as Julia. So I can log in if it's Bentley and Kitties, and I should be able to log in if it's Julia and Italy. So you can log in, but if I do Bentley and Italy, it's not going to log in. So you can see like this, it makes it easier to break down your program, to think about this logic. You have one Boolean for each person you want to allow to log in, or you're using AND to see if the name and the password are equal, and then you're using OR to see if you were successfully logged in as anyone. And then if you want to do a little bit more, just to show you guys not, here I'm going to do if not log in, it's not valid. That's where you can put some error code. Error, you have typed something, you have typed wrong. Police are coming. Flee. Okay. So it's a dramatic message, I must admit. But now that you guys have not, it's very easy to think about this program. You have your login, whether you can log in or not. Is your name equal to Bentley and your password is Kitties, or your name is Julia and password equals Italy? And now you can test to see if something is not true. If you can't log in, if not log in, then you have some error message. You can suggest to the user, hey, maybe you meant to type something different, or you tell them that the police are coming, whatever you want to do. Okay. Any questions about this? Okay, if you're having trouble with ands and ors, go on CodingBat. They have tons of examples for you. Okay, thank you very much.